Find the inverse of the function f of x equals 5x cubed plus 1. Well, remember to find an inverse. This is going to be our y. So to find the inverse, we switch x and y and solve for y. So we want to subtract 1 from both sides. X minus 1 is 5y cubed. We're going to divide both sides by 5. Now to get rid of a cube, we have to take the cube root of both sides. We end up with y is equal to the cube root of x minus 1 over 5. Well, this is now our inverse function. So f inverse of x is the cube root of x minus 1 over 5. So we have this nice picture here. Our original function was 5x cubed plus 1. That's this blue graph right here. 5x cubed plus 1. Remember, your cubic function makes that S shape? Well, remember that inverse functions are reflected over the line y equals x. If you were to graph a cube root function, if you remember your toolkit functions, it also makes an S shape but laying on its side, right? So that's where this graph goes right here. It's this red one. You can see that this blue graph and the red graph are reflections across the line y equals x. Well, sometimes we have to restrict our domain. Now, we mentioned this briefly when we talked about inverses in chapter 3. Instead of reading all of this stuff to you, I'm just going to start working some problems that explain the restricting the domain idea. You have these notes, so hopefully you'll go back and spend a little time reading them. Okay, so look at this first example. Use the graph of the function f of x equals x squared plus 2 to create a new function that is 1 to 1. Well, what's wrong with this one? It's a function. We know that already because it's a quadratic function. But if you look at the horizontal line test, it fails because it touches the graph in more than one place. That means this particular function doesn't have an inverse. But what if, for some reason, what if I were to just cover up this side? Don't you love my nice little cover up there? What if I were to cover up this side of the graph? Would it now be 1 to 1? My line only touches it in one place each time, right? So if I cover up the left side, my graph is now 1 to 1. Well, what if I cover up the right side? Still 1 to 1, right? Well, what if I covered it up starting at where x is -1, so about right there? Is that 1 to 1? Sure. So all you have to do is restrict your domain. So since this one's called f of x, let's change it to g of x. It's still going to be the same function, x squared plus 2, but we have to put a condition on there. Let's say I only want to look at the right-hand side of my parabola. So I have to say, well, x has to be greater than or equal to 0, right? If x is greater than or equal to 0, then I'm only looking at this side of my graph. Well, what if I said x is less than or equal to 0? Wouldn't that also work? That means I'm only looking at this side of my graph. Well, what if I said x is greater than or equal to 1/2? 1/2 would be about here. If I only look from here to the right, I'm still looking at only this piece, which is 1 to 1. So you could continue this process. You could pick any value to restrict your domain as long as you note where you restricted your domain. So this list, you could never list them all. It goes on and on forever and ever. Now, most of the time there is a reasonable restriction, and we'll talk about those a little bit later as we go through the lesson.